Right, this is the start of calculus. Probably wondering what it is. I'm going to start with this graph. It's got this little equation that looks like this. Got a few things off to the side here that I can change the formula, but you don't need to know that at this stage. Some pretty cool little quadratics here. This is just a regular quadratic. Drops down. Alright, so calculus, I'm going to take this point. Calculus, this is where it's going to come from, but it's not actually the use. Calculus is when something gets very, very small. And this is one of the uses where I want to find the tangent. I want to find the gradient of the tangent to this curve. So this is the tangent here. And we're going to use that by... So we've only got 1 point. We need rise over run. So we need two points to do rise over run, which we know from our coordinate geometry. So here's our second point. It's not on this line, but this will just have to be an estimate of the gradient. This is the actual gradient, which we will end up finding in the long run. But we're going to use a gradient between these 2 points. We could see, and we've got the gradient that we want to be is this. The gradient that we've got, let's move this over here. This is the gradient 2, so 6 and 10, that's actually quite a big difference. But if we have a look, I'm going to move those 2 points. So this point I'm going to move closer to the actual point. And when we do that, you see the gradient is getting closer and closer. 7, it's a little bit of distance. And this is what calculus is. Calculus is all about getting things as small as possible. They can't be on the exact point, or else the gradient will be undefined. Because you're doing, well, you've only got 1 point. So they have to be 2 different points. And they have to be super close together. I'm going to use a special trick to see how that's done. First of all, we're going to have to go into... I'm going to get rid of these showing gradients things. Show gradient just to tidy it up. Show P point. So this is the coordinate. So we're just looking at the coordinate. This is this point here. Let's move it up a little bit. Is x, which makes sense because that's x. And this is f of x, which is what our formula is. It's basically just y. Our function, if we put that value of x into there, it'll be that number. So that's that coordinate. This is the second coordinate. They call this h, and I've never really understood it because h sounds like a height, but this is just the change in the x. Alright, so that's our coordinate for the second point. This is x plus h, so there's our x plus h over in for the x coordinate. Our y is f of x plus h, f of x plus h, because you just put an x plus h in. We've got a formula here, so we could actually do it, but we're not going to right yet. That'll be in the next video. We're going to show. So this is the change in x, which would be our run. This is our rise. Rise is f of x. So this is this point and the y value. Take away this point and the y value. So that's just the rise. And the run, get rid of this change of x. What is change of x? I don't need that there. And so that means to find our gradient of the second one, which remember is just an estimate at this stage of the actual gradient, is rise over run, which is equal to rise, this stuff here. I can't put it over there, but it's that stuff there, minus, so this is basically y2 minus y1, and that gap there is h, and for some reason they call that distance there h. I'm still confused. It's not actually a height. It's an x value, so it's in a crossways. So that's why it's just got h. And the key for calculus is we want h to be as small as possible, because remember, if we get those 2 points as close together, then it is the same point. Now this is quite confusing, and I'm sure you're asking, what does this even mean? And we will find out on the next video, so to be continued.